One thing I learned watching guys who are more experienced than myself is that they accept that sometimes you have to take something all the way down, put it back together, take it all the way down, put it back together. As you get better, you can start to avoid that. But in the beginning, you need to be willing to tear it down. And if you're not willing to tear something down, then you're not going to get those big wins. So let's fucking do it. Oh. This is the guy we had fired up yesterday. Exhausting, dude. So I looked over the schematics for a couple hours, and where is he at? This guy. That guy is the main feed to the primary of the transformers. There's 6 of them. These 3. Oh, yeah, I remember checking these now last time. These guys. These 3 and these 3. Feeding the input, and then the output is working on. Something keeps. Oh, fuck! That's what's been clicking on and off. Oh no! I left the BMS on with the contactor for fucking ever, and it's been over here cycling. All right. This is what we need that power supply for, is to charge this. Talk about coming back around, dude. Alright, so this. I've been hearing this thing clicking and clacking all last night. Oh no. Oh, Schindler. Fucking really, dude. I didn't run a BMS, and I left it on to the point where the contactor was shutting down. Okay, this guy's done. Mr. BMS didn't run a fucking BMS. Why would I do that? Tanked him. Turn it down. This thing was fun while it lasted. Bum. Goes to show you, when you hear clicking, go investigate. And we're gonna be in that center shit. I'm gonna fucking take this down. Half-inch. Bugger. I don't have the impact here. There we go. This fucking super oversized. battery helps. I was about to say, the good thing about an impact is it doesn't womp you as hard. But sometimes it does. Alright, Boogie Thruster's dead. Well, at least we know the 24 volt BMS is around. Someone was asking about that. Alright. How do you salvage these? Well, they're puffed. First you read off the cells. Oh. 1 volt. 2 volts. 3 volts. 4 volts. They're still sitting at 1 volt each. Salvageable. Not with LiPo. One, 2.4, 3.6, 4.7. They're all above 1 volt. All right, now once. So now we just have to charge these up. I guess if I'd been a little less hasty, I could have charged them through the unit at 24 volts. But it doesn't have a BMS. It shouldn't be in service. It was built under duress. So that is something we need to build this power supply for. That's what I need to do. Is charge it like that. So onward to the fucking task. That was sad. What this is for? This will put out up to 33 volts, so 24 volt, you figure you charge them up to 3.8. What's 3.8 times 8? I don't know. What's 4 times 8? 32. So you know that no matter what, this is going to be able to charge those all the way up. So we need to tear this down, measure these 3 guys again, then measure this 5-watt Schottky that's next to this guy, and then start looking upstream and see why the hell this thing's only putting out like 20 volts. And while we're under there, let's check and make sure the output caps are good. Wouldn't that be funny if it's just the output caps? You know? It could be. Notice these are Nicholson caps. These are the original caps. They're serial numbered. They're brown. They're just a different, it's a different deal, dude. These aren't sweating a bunch of electrolyte. We'll see how long those other ones hold up. With some more time, waste your life. I'm getting pretty good at this. I believe I'm going to have this one fixed. All our little drawers for holding these are consumed, so we need to have some method or way to keep track of these here fasteners. The teardown on this is going to be the same as the teardown on the last one. I'm going to be down there, same one as the last one, yes sir. tear it on down right here. Gonna tear it down. As a rule, don't tear something down until you have some place to put the fasteners. Could be anything. Old people save shit like this. It's actually pretty useful. So we know that the last things to go on are the AC and the plug. So now we'll look this over. You can see what we're doing here. We're gonna pop this biscuit fan. Just the same shit, different day, dude. You do it for free, you do it for money. Makes no difference. You better love it, or else you're gonna go fucking nuts. It sucks. It's hard. And you don't always win. And you certainly don't know if and or when you are going to win. Sometimes you just work hard for nothing and you lose. So we know that we're gonna have to relieve this. These guys are full of bugs and shit. We're only gonna get to do this so many times before it takes a shit on us. And we get to learn about rebuilding ribbon cables. Now these aren't marked with the same patternizations. So let's cut that zip tie. We know that that's how you fuck up right there. We know that this guy and this guy have to go, so we know he's on top, and on top. See, I'm just marking the ones that go on top. It's arbitrary what you do, but you gotta do something. This time I'm just pulling on the wires. These are professional crimps. They're really good. They don't let go. And the final one you leave unmarked on here, and that's the first one you hook up. Alright, so this was actually soldered in, which was kind of a surprise. I think that's why I didn't take it off before, and I think that's why I missed the solid. Oh, bastards. You got me. Alright, let's go. No washer. I did put these back in though. Block washer. Block washer and washer. Now we're gonna start needing those tweezers. See how shit falls underneath? You can't have that. You cannot have fucking loose washers all over the place. I feel like a bag of ass. Fucking back won't let up. I don't know what the trouble is. I got so much fucking tension in my back. It just keep following it around the edge. Some slight differences between these, but for the most part they're all the same. So this guy's the middle of the road, 33 volts, not 600, not 8. So somewhere along the line, somebody lost a washer. Pretty sure someone touched this before me. I think this one needs to come out. This one has an insulator. You know, the guys on the heat sinks are the long ones, they have insulators. Yeah. No lock washer. I remember garbling this up a little bit when I put it back together. I was like, "Fuck down for me, hold that shit, man. Fucking put that shit back together, yo." And I do remember checking that sextant. Is that what it is? Hex of transistors. But this shit ain't working yet, so tear it down. Figure it. What's going on? Number one. This I'm going to put with the outer stuff. Basically, I'm putting all these, everything that's on the back, I'm putting it around. I think that's what confused me before, too. This is number 2. Know your number 1 and number 2 Phillips, or else you're just going to fail over and over and over. Like that. Well, that's how you lose washers. Okay, all we really need is the insulating washer and the fastener. Those go way over here. Alright, cleared. These need to come out. You know, we use the Jiffy kit for that. Where's my motherfucking Jiffy kit? It's at 9/16. Look out for these, and you make a kit called Sorensen Repair Kit. It's going to have a 3/16, of course. It's going to have a 3/16, number 1 Phillips, a number 2 Phillips, and middle of the road flathead. What do they call that? A 6-8? I don't even know what that means. Santa's gonna come and shit in your mouth. He's gonna steal all your stuff and make you sad. He's coming for you, I have no doubt. He doesn't like you, not one bit. He wants you to fail and have a fit. Santa doesn't like you because you're old. And he's gonna put coal in your stocking. Come on, you filthy bastard. Now, where does this go? The rest of them shit's here. So 2 bins of fasteners so far, 1 internal, 1 external. Alright. Make yourself a little cheat sheet on the manual you printed out, telling you how many fasteners are on the PCB board, what the stack up is, maybe draw little pictures or shit like that. We got to get the rectum fryer out of there. What's that? 1/4 inch looks too big. It's called a rectum fryer because it's a rectifier. And it will fry your fucking ass if you touch it. It has like, I don't know, this one, 500-600 volts peak to peak. Well, 240 RMS. So 240 divided by 0.707. And then you multiply that by 2. That's how much rectifiability it has. Alright, we're clear. See, it wasn't all that bad. But a lot of guys won't do that, and that's why they can't fix shit. It's just a matter of being willing to fucking do it. You got to do it. Yeah, it's scary. Welcome. No one said it's going to be fucking easy, or that you wouldn't be scared, right? A lot of guys, they want to start doing it. They come around, they're like, dude, I want to fucking... See, look. That's one of the 2 original fails. Whoa, there's one of our washers. Score. All of these have had 2 failures so far. And, this failure over here will distract you from the failure over yonder. Multiple failures. Now, we've already read into these capacitors to see that, in fact, they do hold a charge. But we don't know if them there holds the whole charge or just part of charge. They call them part of charge capacitators. Them recycle capacitators. New recyclators. Get in there. Oh, get in there. So, I'm not going to pull these. It's not worth it. Notice it's a cleaner solder job. That last one was clearly a rework job, dude. It's fucking janko, dude. First, I'm going to check resistance and I'll be climbing. Now I'm going to check capacitance. Where's the positive? Where's the negative? Well, we'll figure it. That's odd. Can't get a read. I think they might be too big. Well, I get 8.4 millifarads for a second if I dupe the meter. Now there's a huge discharge resistor on there. And these are 3.3, 3, 6, 9, 10. So we should have 10. And I read 8.4 on a sloppy reading. I think it's fine, dude. Let's get rid of this. I don't want this analog control card. Whoa. Why is this peeling up on me? Is that normal? Alright. So the filter board on this one, Sorensen, a Raytheon company. Goes with the cap up. Don't be go getting on there them backwards. You'll be sorry. Goes like that. Let's go read that. Resistor R, what is it? 981 or some shit. So cooked off. Oh, that might be, it may just be that we need to replace this bastard. It's reading 16.6 ohms, and it should be 10 ohms. And we don't know what kind of circuit it is. I don't think that's it. Q10, 13, 11, Q9, Q7, Q8. So these 6 are what he's humping on. And look, we want to prove that. So we hold up the light. You ain't gonna be able to see, are you? That's okay, fuck you, I can see. Them capacitors, I ate my taters and them capacitors. Right here, this here big long wire right here comes up and over right here to this secondary side, primary side. C79. That's only hooked up, nope, comes up this way, up here, into this whole traces. This here tracer raiders. So, comes right up here, I can't tell whether it hits that or not. If it doesn't, comes up here, hits that, and feeds into all this shit up here. Now that's its input. I'm not worried about that. Now here's its outer tater. It's this rail right here. And then immediately hits into this guy. That's the big 5-watt Zener. We need to test that right away. So in the schematic I showed you this morning, if I did, that's the 5-watt Zener next to it. Alright, the stripe is the cathode. 0.649. Now that if this is a Zener diode, what's going to happen is it reads like a regular diode like this, and you put it the other way, and that's the, you know, that's the. Let me think about that. This should be holding off. I think it's at like 18 volts. Maybe you got to remove it from the circuit. So I don't remember how you test a Zener with just a probe. I don't think this will do it. You need to basically apply a voltage, and it will be like open circuit, you know, low current, low current, low current, and as soon as you hit the knee current, you back it off. That's why you use another power supply with a dial. You set the current down to like 1 milliamp, and you start lifting the voltage, right? And you watch what it does, and you watch that current. And you get up to its knee voltage, like 18 volts or something, and it should fold over and start chugging current. Now, if this guy somehow fails, I don't think it would fail like that. Yeah, dude, it's still behaving. I'm not worried about that. But note to self, refresh on how to check a Zener diode. Okay, I'm just holding the light into the back. And then we hit this little bus, and we jump over with a little puff cap to something. So that's punching through AC. And we are chopping here, right? So I always do my DC analysis first. Now, how do they get over here to these guys? All right, so the heat is coming through this resistor over this. Now it's hitting through this jumper, so you can't use a DC analysis for something like this because old design, right? Well, modern design too. It's alternating current, and so it can fire through a capacitor. And it comes over here and it hits these guys. So be careful, right? You have to consider in AC your caps are short circuits. Just think of it that way for AC. So let's quickly check these guys down here. I don't remember what they are. They could be MOSFET. They're probably MOSFETs. They could be BJTs. But here, here, and here. Here, here, and here. So let's circle that. You can go watch something else. I always get to the fucking root cause. Bruh. Where were we? Oh, it may be a different supply that I checked these out on. Now, if you circle it like that with your Sharpie, and this needs a new thermal pad, you can then look through and see your circles and know if you did it right. Yep. One word of warning. Anything you draw on the board looks like a trace, so don't go tracing your Sharpie marks. How does it go? Well, the first thing to figure out is where the drain is. So you measure from case to a leg, and that'll be the drain. And then you just look for the small traces, and that'll be the. So on this, can you see what I'm doing? Probably not. That's too far away. You just listen here. You'll figure it out. There's 3 legs. 2 of them have heavy traces. 1 of them doesn't. That little one that doesn't is the gate, and the one that touches the frame is the drain. All right. So I can really quickly right now just beep it true, and we'll find out. So I'm going to go over to diode because I'm looking for the. 1.9 volts, 2 volts. I'm lifting, I got capacitance in there. 1.5 volts. But if I go to resistance, $50K. I'm just measuring drain to source now. Like 30 fucking mags. Oh, this one has different wiring. Oh well. Yeah, we're not getting good test data here. Now, alright, that logic doesn't apply. Look, these all have the same size traces. So we're gonna slow down and get the pin out of those. See? You thunk it. So you can go a little bit farther. But you have the part number and you can just look it up. And if you go to anything, it'll be base emitter collector, you know, or there's an ordering to the pins. And from that logic, you can figure it. So let's try to figure it a little bit harder. Let's get some needle probes. Because you're not always going to have Ethernet or Wi-Fi or your computer. You need to be able to figure it. From base principles. So the drain or the collector are always going to be on the heatsink. For every one I've ever seen, anywhere. That's an assumption you can safely make. All right. Set it to vapors. What we're looking for is which pin is touching the case. So I'm touching the case at the top. And if you're doing this a lot, you'll know the pin out by heart. Yeah, it goes to the middle pin. That's very common, and it's also common to see the middle pin missing. The middle pin is either collector or drain. It's the top, it's the cathode of the diode. And then it should go gate, drain, source. Yep, and it says S over here for source. And then this one will be the same. So on the first try, I'll be able to pick it off. Yep. And then, so now let's prove that it's gate, drain, source. We know the drain's in the middle, and we know the sources are inboard here. So I'm now looking through where the traces are. I see two of them are tied together. They're not running very much power. I might have misinterpreted that schematic diagram. Yes, sir. Them there ain't running too much power. But based on the logics that I just used, that there is good enough for me to figure it. So I say this is the source over here. Back to diode. And I say that the cathode should be at the drain in the middle. And I hear a beep, 0.566, and that makes sense. Over here, I hear a beep, 0.561. And over here, I hear a beep, 0.543. We did this before, do you recall? Same goes over here. All I'm doing is checking the drain to source, that it works as a fucking diode. That's it. You can do this. When you apply voltage to the gate, what happens got us one here. A lot of capacitance there. I'm not getting a beep. And then I come over to this guy. Cathode. So I get a beep, 0.548. On this one, beep. Hey, we got one man out. Now, let's focus on this guy right here. That's, can't see shit. Q7. Q7 is not giving me a clean read. So let's check it better. Cathode would be here. Q7's not performing. There's no diode junction on Q7. All right, walk up to another supply right now and measure it. This is called known goods. This is called not known goods swap, but just the old method. All right, still there. I'll pull out another supply because you didn't have the internet, you understand? There was no fucking internet. Now these are different, but they're gonna be the same. So I'm gonna take the same reading right over here. Source, beep. Okay, Q7 beeps over here. We're on to one. Q7 is directly tied to the overheating resistor, which should be 10 ohms, which is actually 16 ohms, and one of those FETs or BGTs or whatever they are is not showing me a diode junction. Next step is measure it for resistance. Ohms between the back pad and the source. Wouldn't that be funny this whole time if I was reading to the gate and I was just doing it wrong? Either way, you're going to get consistent readings. And if you have an odd man out, that's your problem. Two mega ohms. Comparison. 2 mega ohms. It could be that there's like something in, no, the other board's gonna be just the same. I say, now these usually fail short. I don't see any cracking on its case, but I do have good reason to believe that it got punched in the nuts. I would be inclined to pull Q7 out of there, drop it in here, pull our whatever it is. Remember we had to intuit what this number was because we couldn't fucking actually read it because it was burned off the silk screen. We had to like do a process of elimination. I would pull a good 10 ohm half watt and a good transistor MOSFET, whatever, replace this part and this part, fire it up. I'm going to go to the schematic and see what job Q7 has. That's not what I expect to see, though. I'm used to seeing something different. Dude. Maybe that's why I missed it before. All right, see 10 kilo ohms between the gate or the base and the source. So that would be the pull down resistor. The pull down resistor still exists on the base. I think it's this and this. And I think it would still sort of work even with that like it is. Them there troubleshooting manual. Good luck reading this. Yeah, there's no search button, bruh. If you're searching in Altium, you need not apply. You will not find the answer here. This is the resistor right here. Those MOSFETs are right here. I can't read it. Q7's right here. So we read, let's go find that 10 kiloohm. Here's the 10K I read on the base or the drain, whatever it is, to earth, to ground. And then here's the source to ground. So if this guy goes open, this is a control FET to drive this guy up here. Yeah. Oh, dude, this is a sneaky one. Okay, so on the low side, this is early MOSFETs, I'm pretty certain. On the low side, they're directly driving, low side drive, all right? On the high side, they're using a pair, and the first one's job is to drive the second one. So the second one, so this will be like a normally open N channel. And this one up here is going to depend on this one down here. This is a P channel up here, and it's got a pull-up resistor going to the high side. And so if this Q7 fails, then this guy turns on and stays on. That's my supposition. And he failed to open, probably got blown open. I don't understand what happened or why. But if you float Q7, then you're no longer pulling on the gate of Q whatever this is up here, and it's firing through at all times. And so you're going to get real piss poor behavior. You're going to get a straight shot through this burnt resistor. Right up here to the top of this transistor, MOSFET, whatever, and right down here through the primary, and then it's going to be pulsing with this. So basically, half the circuit or a quarter of the circuit's on all the time. That would make sense. So I think we need to we go look up Q7 and replace it. Parts ordering. So this is the front panel assembly. This is the power assembly. There's common parts and there's not common parts. There's common parts and specific parts. Q 6 through 12. That's us. We're 7. Q7 is open on the 33-33 PS. That's an MTD 5N05, 50 volt, 5 amp, 0.4, 400 milliohm D-pack, dude. Brah. All right, so let's go confirm. Notice that those are all the same, and they're not particularly impressive. So 13 through 16 are the 450 volt 13 amp. These are the ones doing the real work. And these are the ones driving the other side. I think I still don't understand how this circuit works. But basically, you get a totem pole and a totem pole yanking on what the schematic shows me is a part of a transformer. And maybe it's just something that an old analog design engineer would be like, yeah, duh, don't you know what that there is? But I don't know. So I know one there is fuckered up down there, though. One of them control ones. So we're going to make the circuit right here. All right, and there's like a coil, and it comes over here again. So we have low side switching on it and a high side. Now this goes right over to a control, and over here you have another one. And then this goes up to a resistor to here, the high side switch. So this is an N-channel device in high side mode, and the driver for it has taken a shit. And I've seen this part blow out on a lot of circuits. So I think I got root cause. I think I'm about to get paid. He thinks I failed and he thinks I won. I say that Q7 is this part and that it's done blowed out. That there blowed out. And I also say that this here circuit right here, on this here side of the circuit is the big MOSFETs that makes the 450 volts go wump bump 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 bump. And on this side, all I see is here's the material, right? The iron, and I see here's the coil. This is an N channel, and this is an N channel high side, and that's its pull up on its gate. And this is the helper that's yanking on it in order to see, tied right down here to the same gate drive. So the same gate drive puts these out of phase. Now you get the same circuit down here. You get the low side, and you got the N channel and high side, and you got the helper, and you got your gates tied together. Q7's open. It is not showing a body diode, and that keeps this guy, well, it's powered in the on position, which you can't read when it's off, and it is directly hooked up to the resistor with the smoke coming out of it. And so what's the path? The smoke is coming out of here because this guy's supposed to be on only like half the time or whatever when he's on all the time. And every once in a while he's fucking when this guy down here fires and he's supposed to open, he stays closed and it fires right here to ground. So it's going bah, smoke in that batch. I got root cause. Time. What do you want to bet? You want to bet with me? You won't bet against me, because I always fucking win. I might be wrong this time, but I'll be right eventually. Think I'm right this time or next time. Everyone knows you are my heat. Now, do you want to just right now pull a part we need, stick it in there and test it, or do you want to order the parts, wait around for 3 days? That's why I need to scrap one of these, dude, to pull parts off of. I don't want to break one of the other supplies to fucking test this one. That shit's whack. We could energize it right now and prove that's true by putting the scope on a good working one and looking what the signal looks like across, Q7 and the one above it, and then show on this one that it's pinned high. But that's just smoking parts, dude. I don't think that, I don't think that's helpful.